In section 2.3, we will talk about some word problems. And here are the steps. Read the problem, underline any information that might be relevant. It helps us organize the information. Number two, identify what you're solving for. Most often, this will be your variable. Label the variable. Step three, create a drawing and or table to organize the problem. Step four, create and solve an equation. Step five, write your answer using a complete sentence and check your work. If I should include on this, make sure you put units, super important. Okay, so first one, two cyclists 42 miles apart start riding towards each other at the same time. One cycle is 2 times as fast as the other. If they meet 2 hours later, what is the speed, miles per hour, of the faster cyclist? So let's go through and read this again. Underline the important information. Two cyclists are 42 miles apart. So when we make our drawing, we're going to make them 42 miles apart. They're riding towards each other at the same time. One cycles 2 times as fast as the other. So that's important. One cycles. So this tells us something about their speed. 2 times as fast as the other. And they meet 2 hours later. What is the speed? So this tells us what our time is. What is the speed of the faster cyclist? Okay, so we read the problem. We underline any information. Identify what you're solving for. That's super important. Start with the question. What is the question asking? What is the speed of the faster cyclist? So we can say we use whatever variable. Let's just use x. So let x equal to the speed of the faster cyclist. Okay, so now we know what we're looking for. Create a drawing and a table to organize the problem. So let's start with a drawing first. So this is cyclist number 1 and cyclist number 2. And here's what we know. They're 42 miles apart. So the distance between them is 42 miles. They start riding towards each other. So they start riding towards each other, and at some point they're going to ride, 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 and they're going to meet. So they meet here or wherever it is. And the time, it's 2 hours. They meet after 2 hours. So the total time taken. So each cyclist is riding for 2 hours. First one's riding for two, second one's riding for two at the same time. So the total time is 2 hours. Now let's make a table. Anytime you're given a problem with some kind of speed, some kind of time, distance, we are going to use a table like this. We have our rate, we have our time, and we have our distance. And distance equals rate times time, which we'll talk about later. So we have two cyclists. We got cyclist number 1, cyclist number 2. What do we know about them? We know that one cycles 2 times as fast as the other. So it says that let x equal to the speed of the faster cyclist. Okay, let's let x equal to the speed of the faster cyclist because that's what we're looking for. So that'll be our x. The rate of the faster cyclist is going to be x. The other one cycles 2 times as fast as the other. Okay, so let's think about this. If the faster cycling is going at a rate of x, and this faster cyclist is going 2 times as fast as the other, then the slower one must be going half as fast. Or if you want to make it simpler, we can make let x equal to the speed of the slower cyclist. Now, how does that help us? Because then we can say that let 2x equal to the speed of the faster cyclist. So instead of dealing with like half of x, which is going to be x over 2, instead of dealing with fractions, let's just do this. Let 2x equal to the speed of the faster cyclist. So the speed of the faster cyclist is 2x. They each ride for 2 hours, so the time is going to be 2 hours. Now the distance for the first cyclist is given by rate times time. That's going to be 2 times x. For the second one, it's rate times time. That's going to be 2 times 2x, or 4x. And here's what we know. We know that they were 42 miles apart, so their total distance was 42 miles. So the distance ridden by the first cyclist plus the distance ridden by the second cyclist is equal to 42 miles. That's an equation which we have to solve. So 2x and 4x gives you 6x equals to 42. Divide everything by 6, that gives you x equals to 7. Now what does x represent? In this case, we switched it and we said x equals to the speed of the slower cyclist. So 7 miles per hour, that's the speed of the slower cyclist. The faster one goes twice as fast. So 2x, that's equal to 2 times x is 7. So 2 times 7 is going to be 14 miles per hour. And that is the speed of the faster cyclist. So write your answer using complete sentence. So we're going to say the speed of the faster cyclist is 14 miles per hour. And if you want to check that, we can plug it in. So we have our table, we have our rate, we have our time, we have our distance. We said the slower cyclist goes at 7 miles an hour, the faster one goes at 14. The time is 2 because they both ride for 2 hours, so 7 times 2 is 14. The first one rode for 14 miles, the second one 14 times 2 is 28. If you add their combined distance, it should give you 42 miles, which it does. So our check makes sense. And this is our final answer. Okay, let's do another one. You are choosing between two different cell phone plans. The first charges a rate of 24 cents per minute. The second plan charges a monthly, so the first one has no monthly fee. The second plan charges a monthly fee of $49.95 plus 11 cents per minute. So the second one, their charge per minute is lower, but they have a monthly fee, whereas the first one doesn't. How many minutes would you have to use in a month in order for the second plan to be preferable? Round up to the nearest whole minute. So read the question. Let's underline the relevant information. The first plan charges a rate of 24 cents per minute. Second plan has a monthly fee of $49.95 plus 11 cents per minute. So what are we looking for? It says how many minutes, so that's what we're looking for. So we're gonna, in this case it's minutes, so we can use x, but I'm just gonna use m. So we're gonna let m equal to the number of minutes. Okay, let's make a drawing. So we have two different plans, so let's write those down. We got plan 1, and we got plan 2. So the first plan has a rate of 24 cents per minute. So the cost of the plan is 24 cents, which is 0.24 for every minute you talk. Let m equal to the number of minutes. So if you talk for 1 minute, it's 24 cents. 2 minutes, 48 cents. So it's going to be 24m. There's no monthly fee. So that's the cost of the first plan. Cost of the second plan, you have to pay a monthly fee of $49.95. So let's say you lose your phone and you don't talk at all. You still have to pay the monthly fee. Whereas in the first case, if you lose your phone and you don't talk at all, you don't pay anything because you don't use any minutes. But in the second plan, you have to pay this monthly fee, plus you got to pay 11 cents per minute. The question says, how many minutes would you have to use in a month for the second plan to be preferable? So we want to find out when are these two plans equal. So we're going to say that we want the cost of the first plan to equal to the cost of the second plan. Cost of the first plan is 24 minute is given by 0.24m. It's 24 cents per minute. Second plan is given by 49.95 minus 0.11m. So now this becomes an equation which we can solve. We can start by adding 0.11m to both sides. So this gives you 0.35m equals to 49.95. We move all the variables to one side. We can now divide by 0.35 because our goal is to get the m by itself. So if we take 49.95 and divide that by 0.35, we get the following. we're going to get m equals to 142.7. But you can't talk, I guess you can talk for 0.7 of a minute, but you have to round. So we're going to round this to 143 minutes. So write your answer using complete sentence. So the question was, after how many minutes would the second plan be preferable? So we're going to say after 143 minutes, the second plan is preferable. Or I'm just going to use better. Okay, let's do the next one. A rectangular room is 2 times as long as it is wide. So underline relevant information. A rectangular room is 2 times as long as it is wide, and its perimeter is 30 meters. Find the dimensions of the room. So what are we looking for? We're looking for the length and the width. Okay, so identify the variables. So we're looking for the length, which we don't know, and we're looking for the width. But here's what we do know. A rectangular room is 2 times as long as it is wide. So it's the length is 2 times longer than the width. So if we let the width equals to x, the length is 2 times that. Now create a drawing. So let's create a drawing. In a rectangle, we have a length and we have a width. The length is given by 2x. And remember, the opposite will also be 2x. And the width is given by x. The perimeter is 30. How do you get a perimeter? The perimeter, it means you add up all the sides. So if we add up the length, which is 2x plus 2x, the width, which is x plus x, that equals to the perimeter, which is 30. So 2x plus 2x is 4x, plus 1 is 5x, plus 1 is, so remember there's an invisible x in the front. So 2x and 2x is 4x, 5x, 6x, so we have 6x equals to 30. We divide both sides by 6, and we get x equals to 5. So what does x represent? X represents the width. So the width is equal to 5 meters, and we have to make sure that we include the units. So the width is equal to 5 meters. The length is 2 times that. So the length is 2 times that, which is 10 meters. And we already wrote the answer, so that should be good enough. All right. Think of questions, and we will go over all this in class.